Hi all. So welcome to a video and what we're going to talk about on this video is a little bit of basic chemistry. And so I'm going to have up the PowerPoint slide that's the same as the one we're going to be using in class, but we're going to cover the first 9 or 10 slides here in this video. And then I have a list of things that you are responsible for knowing from this video, and when you come to class we'll have a really short 3 to 5 question quiz to make sure that you have covered that material. And the purpose of this, as you see as we go through class, is to allow more time for applications and for us to go over some of the harder things in a little more in depth to help you out with learning the content better. So let's go ahead and get started. So we're going to review a little bit of very basic chemistry. If you have had Chem 105, then you have already had all this, or Chem 111 as well, or chemistry in high school, frankly, you may have had it, though it would be nice to maybe review it a little bit. For anyone that's never had chemistry before, you might need to watch this video a couple of times to make sure that you're understanding it. And of course, I'm very happy to talk with you about it during office hours and help clear up anything that you need help with. So there's a large variety of elements that are found in the human body. If you look at the periodic table up here on this, you'll see everything that's highlighted in green or blue is found in the human body, but the most common ones are in green. And of those, oxygen is by far the most common, primarily because so much of the body is made up of water. So what we're going to focus on in this next little bit is some basic information that you need to understand in order to understand how bonds are made, so ionic bonding and covalent bonding. But why that's important for human physiology is to be able to understand the relationship between water and what we call electrolytes. And so we'll talk about that aspect of it in class, but the background necessary for understanding that concept we're going to do in this video today. So first off, atoms themselves are what's considered the building block of an element, and they're made up of what are referred to as subatomic particles, of which there are 3 kinds. So if you're looking at the subatomic particles, then they are the proton, the neutron, and the electron. And these all differ according to location, so where in the atom do you find the particle, according to their mass, and whether or not the subatomic particle has a charge. That's the word charge there. So protons have a positive charge. They are found in the nucleus, and each proton weighs 1 atomic mass unit. Neutrons, on the other hand, are neutral, which means no charge. They are also found in the nucleus, and they also have a weight of 1 atomic mass unit. Electrons have a negative charge. They're found in what are referred to as orbits or shells, which are located on exterior to the nucleus, and they have such small weight that they're referred to as having 0 atomic mass units or mass. So part of what you need to be able to do is to figure out, based upon information given on the periodic table, how many protons you have, how many neutrons you have, and how many electrons you have. And the way that that's done is, if you look at the periodic table, oh my goodness, that's going to annoy me. And you too, probably. If you look at the periodic table, for example, if you want to look at magnesium as a choice, it'll look something like this. And this top is referred to as the atomic number, and this bottom is referred to as the atomic mass. And so the atomic number tells you how many protons are present in that particular atom. So the fact that magnesium has an atomic number of 12 means that there are 12 protons. And the atomic mass tells you that the particular atom weighs 24 atomic mass units. Now, since you know there are 12 protons, and each proton weighs 1, that means 12 of your atomic mass units are made of protons, and your other 12, in this case, since 24 minus 12 equals 12, are your neutrons, since each neutron weighs a single atomic mass unit. So that means you have 12 neutrons as well. Now, the other thing about atoms that's important to keep in touch with is that an atom itself is chargeless. They are neither positive nor negatively charged in the atom state. So if you have 12 positive charges, in the case here as a proton, then that means you must have 12 negative charges. So in the case of magnesium, you have 12 protons, 12 neutrons, and 12 electrons. The atomic number will tell you the number of protons. The atomic mass will tell you the number of protons plus the number of neutrons. And then you can use the charge to figure out how many electrons you have. Let's try this with another atom, just for practice. So fluoride has an atomic number of 9 and an atomic mass of 19. So as a reminder, the atomic number tells you directly how many protons you have. So that means you have 9 protons or 9 positive charges, and that those 9 protons together weigh 9 atomic mass units. And then your weight is neutrons plus protons. So if you have a weight of 19, that means you have 10 atomic mass units assigned to the neutrons, which means you have 10 neutrons. And then as a reminder, fluoride in the form of an atom is neutral, no charge. So if you have 9 positive charges, that means you must have 9 negative charges. So therefore you have 9 protons, 10 neutrons, and 9 electrons in fluoride. The next step with this is to be able to draw the atom. So, and that's typically done, the way we're going to do it is to draw it in what's referred to as the orbital model. So here's a couple of examples of that. So if we were to draw fluoride, for example, we would draw the nucleus, and in that nucleus you would have your 9 protons and your 10, neutrons. And then around the nucleus you have orbits. And there's some rules of thumbs about how many electrons can be in each orbit. So in the first orbit, you can have a max of 2 electrons. In the second orbit, you can have a max of 8 electrons. And in the third orbit, you can have a maximum of 18 electrons. So in the case of fluoride, where you have these 9 electrons, you have 2 in the first orbit and 7 in the second orbit. And so that basically means you don't have a third orbit because you don't have enough electrons there. So let's go back and look at this for magnesium. So as a reminder, magnesium has 12 protons, 12 neutrons, and 12 electrons. So let's draw magnesium. So protons of 12, neutrons of 12, electrons of 12. So in the nucleus, you have your 12 neutrons and protons, and then you have your orbitals, and in the first one you have 2, and in the second one you have 8, looks like 28, but it's not, and in the outer one you have 2. So that's what the orbital model for magnesium would look like. Okay, so now let's review just a little bit about bonding. And we're going to talk about a little more of the details in class and just focus on some of the definitions here. So there are several different types of bonding that we're going to cover. So one is referred to as ionic bonding. The next main category of bonding is covalent bonding, which can be broken down into polar bonds, nonpolar bonds, and a special subclass of covalent bonding called hydrogen bonds. I'm really trying hard to get better with this pen. I promise it'll get better. Right now it looks like a 3-year-old wrote it. And right now it looks like my daughter Brana down here wrote it. Let's see, lost my page. So, ionic bonds. So ionic bonds are one in which electrons, in the process of bonding, electrons move from one atom to another. So for example, and I'll show you how this works a little closer in class. Sodium chloride, salt. When sodium chloride is together in the form of this molecule here, it doesn't have a charge, but electrons have transferred from the sodium to the chlorine. And so when you put it in water, it breaks apart. And when it breaks apart, sodium has lost an electron, which means it now has a positive charge because it has one more proton than it does an electron. And chlorine has gained an electron because it now has one more electron than proton. So there's an electron, that moved from sodium to chlorine. And we'll look at this a little more closely in class and why this breaks apart in water. But ionic bonds are ones that create ions or charged particles. So in the process of the bonding between the sodium and the chloride, you have created charged particles. You created a positive sodium atom, which is now referred to as an ion, and a negative chlorine ion. Positive ions are called cations. And I remember that because the T in cations looks like a plus. And negative ions are referred to as anions. Covalent bonds are ones where rather than an electron moving from one atom to another, instead the electrons are shared between the atoms that make up that molecule. And when you're sharing anything, you could share things equally, like you could take a candy bar, divide it in half, give half to someone else and keep half yourself. That's equal sharing. Or you could share things unequally, and when you divide up the candy bar, you give them one little tiny piece and you keep the rest for yourself. That's unequal sharing. And when electrons are shared in the forming of a molecule, it happens the same. It can happen either way. And so polar bonds are unequal sharing. When they're sharing the electrons, one portion of that molecule tends to keep the electrons more frequently. So and a good example of this is water, which you may have seen drawn like this before. It kind of looks like Mickey Mouse. You have your oxygen and your two hydrogens, and they're sharing electrons. So electrons are sort of moving all around this molecule, but when they move around, if you sort of imagine how much time the electron spends around the hydrogens versus the time the electrons spend around the oxygen, the electrons tend to spend a lot more time around the oxygen, which means the oxygen portion of this molecule tends to have a negative charge because there's more electrons over here on that side. And the hydrogen portion of the molecule tends to have a positive charge because the electrons spend less time there. Nonpolar molecules are ones in which the electrons are shared equally. that's, doesn't look quite right. So an example of a nonpolar molecule would be CH4. So you would have carbon in the center and 4 hydrogens around that carbon, and the molecules, or the electrons are moving around and spending equal amounts of time in each location. So they're sharing them equally. Hydrogen bonds are also a covalent bond, but we don't really talk about them that much in regards to electron sharing. Instead, a hydrogen bond is one that is defined by the types of atoms involved. So anytime you have a bond between a hydrogen and oxygen, that is a hydrogen bond. So this is a hydrogen bond and that is a hydrogen bond. So within this molecule there are 2 hydrogen bonds. Or a bond between hydrogen and nitrogen, that is a hydrogen bond. And hydrogen bonds, you'll find as we go through, are important because they help to form 3-dimensional structures, and that 3-dimensional structure is often necessary for molecules to perform a function. This is very critical for DNA. In order for DNA to work like it needs to, you have to have these 3-dimensional structures, and proteins as well. But the other thing that's important is this bond between hydrogen and oxygen, or hydrogen and nitrogen, is very weak. So it's very easy to break that bond. It doesn't require much energy. And in order for these molecules to work, you need to be able to break those bonds easily too. So they form 3-dimensional structures that are easily broken, and that's the function of a hydrogen bond. So what we covered in this little short video is you need to know the location, mass, and charge of electrons, protons, and neutrons. You need to know how to draw an orbital model of an atom. And you need to know the definitions of the major bond types, ionic, and then the 3 types of covalent. So when you come to class, there'll be a really short 3 to 5 question quiz answering these, and then we'll move on to new material. Thanks for your attention.